Good morning, good afternoon, good evening. For anybody who are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have discussed about the displacement time graph and displacement distance graph. In this class, we will be discussing about the relation between wave length, wave velocity, time period, and frequency. Okay, so let us first come to the relation, then we will be discussing about echo. Okay, so what is actually, so make heading relation between wavelength, it is denoted by lambda, wave velocity denoted by letter v, time period t, and frequency f. Okay, so what is the relation? Now see, what we have already learned the specific term wavelength. What is wavelength? It is the distance traveled by the wave in one time period. So if I say what is lambda wavelength, it is the distance traveled by wave in one time period. Okay, so this is the distance traveled by wave in one time period. This is the lambda or wavelength. Okay, so as we know, speed is distance by time. So can we say that if the wave velocity is v, then if we multiply the wave velocity by the time period, which is actually the time, we will get the length. So we can easily say that this is equals to velocity of the wave into time period of the wave into t. So this is the relation. So we are getting lambda is equals to v into t, and we know that time period is reciprocal of frequency. So we can easily say that v into 1 by f. So this is how these three terms are related to each other, or these four terms are related to each other. Okay, so I hope you understand the relation. Okay, we can solve numerical problems based on this small relation. Okay, next we will be coming to the next topic. The next topic is echo. So what is basically echo? Okay, what is basically echo? Let us see. So next topic, make heading echo. Okay. Next topic is echo. So what is echo? See, in human ear, any sound which is coming to the human ear persists in the human ear for about 0.1 second. Okay, just wait a second. The video has been a little bit blurred. Okay, so what is echo? And now I think it is clear. Yeah, it is clear. So any sound persists in the human ear for about 0.1 second. So any sound for an average healthy human persists in human ear for about 0.1 second. Now within this time period, if another sound reaches our ears, we are not able to hear that sound, or in other words it can be said that the brain is not able to record or distinguish that sound. Okay, but what happens if a sound comes after this 0.1 second? Our brain will be able to process it and will be able to hear that sound. Now you know that light can be reflected. We have learned that light can be reflected from a smooth surface. Do you think that sound can also be reflected? If you are thinking yes, then you are exactly correct. Sound can be also reflected as light wave. So light can be reflected, similarly sound can be also reflected from smooth plain surfaces which are shiny in nature, and if the surfaces are rough, they are soft, then sound gets absorbed in those kind of surfaces. So if you are standing in a room and say some person is speaking, the sound of that person reaches the ears of the audience, okay, and at the same time the sound from the person gets reflected from the various walls of the room. If I consider that the rooms of the walls are good reflectors, those sound gets reflected from the walls of the room, and then again might reach the person's or the audience ear of the audience once again. So what will be happening? The audience will be hearing the same sound repeatedly twice or maybe thrice like this. So it will be quite difficult to hear the speaker speaking because the sounds will be overlapping. Okay, so this kind of thing that is happening, that if sound is reflected back, okay, after that 0.1 second, and then it can be heard after the original sound has just died out, then this kind of phenomenon is called echo. Okay, so basically echo is nothing but the hearing of the sound after the original sound has ceased in our ears due to the reflection of sound from various points or various surfaces. That is echo. Okay, now do you think that while sitting in a small room and a person speaking in front of some audience, can echo be produced? The answer is no. So what is the reason that echo is not being produced in very small rooms? There is certain criteria, there is certain minimum distance. If that distance is not present between the producer of the sound and the reflecting surface, then echo will not be heard. So as I have said, see, I am drawing a figure. Consider, say, this is a wall which is actually reflecting sound, okay, and a person is standing in front of the wall at a certain distance, say D, okay. Now the person produces some sound, the sound goes from the mouth of the person, hits the wall, and then again reverses back and comes back to his or her ears. Okay. Now what happened? If I consider that the minimum time after which the echo can be heard is 0.1 second, this is because sound persists in our human ear for 0.1 second. It can be said that what is the minimum distance required for hearing the echo? So we apply the formula, speed is equals to distance by time. Now what is the distance traveled by the sound here? The distance is 2d, and the time within which it is returning, it must be at least 0.1 second. So if I consider that the sound is traveling through air, what is the speed of sound in air? It is about 340 meter per second. So considering that 340 meter per second as the speed, we can say that 340 into 0.1 is equal to 2d. Then what will be the value of d? Then d will be equals to 34 by 2, that is equals to 17. Now if you consider that the speed is meter per second, then the distance will come out in 2 meters. So about 16 or 17 meters is required. This is the least distance. It can be approximated to 16 meters also, not less than that. So approximately can be 16 or 17 meters distance is required between the producer of the sound and the reflecting surface. Only then echo can be heard. So if a room is large enough that the walls of the room are 17 meters away from the speaker, okay, then there is a chance that echo can be heard by the audience. And generally what happens, we have seen that in large auditoriums or large cinema halls, the walls are quite far apart, and the distance between the walls and the sound producing device is about, it can be greater than 17 meters also. So there is a chance of hearing the echo. So to prevent the echo from being heard again and again, what is made? The walls are covered with some soft surfaces like velvet, okay, that absorbs the sound and the echo is prevented from being produced. So this is all about echo. So I think these two small concepts are clear. There is 2 or 3 more terms to be discussed. We will be discussing that those 2-3 terms the next class, and then we will be doing some numerical problem in the another class, and it will be the end of the chapter sound. Okay, so with that we come to the end of our class. If you have any query, please do mention it in the comment box. We will be happy to solve your problem. With that, we end our class today here. Thank you. Goodbye.